So this factoring by grouping, again, here, we've done this before. The only type we did before was 2 by 2. Okay, 2 by 2. So as soon as we looked at this, we said 2 by 2. If it didn't work in that way, we had to go, okay, it didn't work, I got to try it again. So try here, these two. Do they have a common factor? X cubed plus 1? No. Do those two? Yes. But if I did the x squared plus 1, is that going to bring me to an x cubed plus 1? Is that going to make it any closer? No. So that's really not going to help me. So what I would do is I'd look at it and go, wait, these seem to be in a little bit of a mismatched order, right? So remember how in grade 9 we were saying descending order, ascending order? How about if I rewrite it? So here I'm going to rewrite it. I'm going to go x cubed plus x squared plus x plus 1, which is essentially doing, instead of doing it 2 by 2, I'm going to go 1 with the 3 and this way. So let's see if I can mismatch it, right? I'm going to match it with 1 with the 3 and the 2 with the 4. You don't have to show me this step, right? So this one, if you don't want to reorder it, you don't have to. You can just say, I took the 1 in this, and then you're going to go with this, and you're going to say, okay. So I took the x squared out from the first, these two, 1 and 3, which is what I'm showing here, and I go x plus 1. I didn't have a common factor for the last two, so I just left it plus x plus 1. I'm allowed to put a plus and a bracket around it because it didn't affect anything. Okay? So this next one here, I'm going to take out that common factor and go x plus 1 and write down what's left over, right? So the common factor is x plus 1. I write it once, and then I write down what's left over. What is left over? X squared plus, what's the invisible number here? 1. Yeah, so please fill that 1 in here, right? So there's an invisible 1 there. I don't need to see it here in the question, but for the answer, make sure you put the 1 there. Some people go, nothing? It's not nothing, it's 1. Right, so there's an invisible 1 there. So that is common factored out by 2 by 2. So if 1 and 2 doesn't work, then you try 1, 3, and 2, 4, right? So you don't have to write this out. You can just go straight there and go, I did 1, 3, 2, 4. A lot of people write it out just so they can see what's happening. Okay, the next one, try it again. Is there a common factor between the first two? Yes, x. There's an x, so it would be x minus 6. So keep x minus 6 in your head. Is there a common factor here? No, but what is it? What's 9 minus 4y squared? 9's a perfect square. 4y is a perfect square. It's a difference of squares. Does that help me? Because some of these questions, we're going to have that now. If I do a difference of squares here, okay, so in my brain I'm going, difference of squares would get me 3 minus 2y, 3 plus 2y. Does 3 minus 2y and 3 plus 2y help me get to x minus 6? No. Okay, so it can't, that didn't help. Good try, though. Good try, because you're like, okay, but I tried it because there's a difference of squares. So then I go, okay, well, I don't have. What if I try what I did last time? 1 and 3, so x squared plus 9, and 6x in the 4y. Is there a common factor between x squared plus 9? No. So I'm stuck. So there's nothing to do. Now we have a new one. We're going to star this one. Also a new one. Okay. This one here, we're going to do 3 by 1, not 2 by 2. Okay, so 3 by 1 sometimes works. And we're going to grab this whole part here. Can you recognize that that is a beautiful trinomial? X squared, middle term x, 9. Multiplies to 9, adds to negative 6. Can we find numbers that multiply to 9, add to negative 6? Yes, we can. That would be x minus 3, x minus 3. Can I just square it? Do that faster? Okay. So you might go, but it's still not a common factor with 4y squared. I never said this was going to be a common factor one. The other type that we taught you was a common factor type. This one here is a difference of squares. So this becomes a difference of squares. See how it's a perfect square minus a perfect square. So then we're going to go ahead and do this difference of squares, which is exactly what we did last day when we did difference of squares. So let's practice that. We've got. Now, you can use round brackets or square brackets. Yep. You can use round brackets or square brackets. Up to you. How about I use square just to emphasize it? But I don't care if you use double round or square round, okay? So I'll use a square just to emphasize. So square, and I want 2 of these here. So x minus 3, there's one here in red, right? I'm going to put that first and last, or first and first, because x minus 3 times x minus 3. Does that make sense? Because it's 2 of them, so break that up into the 2. That's right, x minus 3, x minus 3. The minus 4y squared, I'm going to break that up. So it's minus 2y and plus 2y. Okay? Do I leave it that way? No, I don't like these extra brackets. I always want you to clean things up. If I don't need it, I don't want it, right? So if I didn't need that, could you have skipped that step and said, well, I already saw I didn't need it? Yeah, right? So if you're like, you know what, I already don't need it, I'm going to take it off. That's okay. I'll show you one where you had to put it in, though, because then it multiplies in, so just be careful. X minus 3 minus 2y, and this is x minus 3 plus 2y, and that's it. Beautiful. That's gorgeous. Done. Fully factored. Beauty, 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 fully factored. All right, we can try again. I have 4 terms, so I either do 2 by 2 or 3 by 1. 2 by 2 or 3 by 1. Now, if I try again 2 by 2, I have, oh, what do you think that is? Yeah, difference of squares, 5m and 6, 5 and 6. Is that, no, it's not going to help me, right? If I had the 5 and 6 here, that'd be good. But here, it's not going to work. Okay, so then if I try the next 2 by 2, so first and the second, that would get me common factor of 5m. Does that help me? It's not really going to help me. Look, I've got 5 and a 2. I got a 36 and a 1. Right? When we're doing 2 by 2, you're looking for matching sets. If there's no matching set, like this, the 2 by 2 really doesn't help. Okay, so we need matching sets. So I either need common or I need this. This one's new. Okay, now let's try this one now. Can you find a group of 3 and 1 to try to do this difference of squares again? So 3 and 1. Which 3 match? 1, 2, 3, and 4. Okay, 3 of them make a trinomial. Which 3 make a trinomial? Which 3? 25m squared, 36n squared, 10m plus 1. The only 3? Yep. That's it. 25. So we're going to highlight. So we're going to go from this one to this one to this one. Those 3. I'm going to rewrite it. I really do like to rewrite it because otherwise it's harder to follow. Again, right, you're telling your story. You're telling me what's happening. Okay, so I rewrite it with those 3 right here. See how pretty those are? That makes a gorgeous little trinomial. That is a beautiful, perfect square trinomial because it's going to be, and again, you can do this on the side if you want, 5m, 5m, 1 and 1, and look, 5 and 5 make 10. It's a perfect square trinomial. This ends up factoring like this again, because it's plus and plus. So that's why. So you need to be able to do, that's what I mean by you need to be able to factor a little bit faster, right? I'm not testing your speed, but at this point I need to test your knowledge of being able to recognize the factors, right? So if this is taking you 10 minutes to do, you need to do enough so that it takes you 5 minutes to do, right? Like, okay, I'm doing it faster, I can recognize it. So you're looking for that beautiful perfect square, and look at that. Now I have a difference of squares. That's the goal. So perfect. Difference of squares. Okay, so you'll see that a lot. Okay, you're creating that difference of squares. And right in grade 10, you did a bunch of these guys, right? The difference of squares. You did, yeah, we did a bunch of these ones. Difference of squares, the difference of squares with the brackets, double brackets. We did all those difference of squares. Now you're making your own. You're creating it. Okay, we're not done because that's not factored. Is that factored form? No, because it's not multiplication, right? It's still minus in between. So now we want to do, again, you can use square brackets if you want. If you don't like the square, you don't have to. I do it just to emphasize what I'm doing. This one goes into both. Do I need a bracket for the first here? Is it doing anything? No. So you can take it off. If you're not sure and you want to take it off the next step, you can. But in this case, I can see it's not going to hold anything together. I don't have to multiply. So I'm going to take it off right away. Okay. If you need one more step, then do one more step and go, okay, I like the bracket, and then I take it off. But that's what's happening. Am I done? Can I do any more? No like terms, I'm good to go. Right? Stuck. Okay. Try it again. So these are the new ones I was talking about, right? I said we need you to know all the types of factoring, and then we're adding just a little bit of extra. So here we have 4 terms. Let's try 2 by 2 first. Unless you see it right away. Unless you're like, you know what? I see them. I can see the trinomial. I don't see a trinomial here. I don't think we can do a trinomial. I don't see a trinomial at all. So let's try 2 by 2, right? So don't forget your grade 10 method. 2 by 2. So these first two, if I common factor out 2, I'm going to be 2 and a 3. So I just look at the numbers first. 2, 3. Can I get a 2? I can't really get a 2, 3 out of that, right? If I can't get the numbers, I'm never going to get the letters, the variables. Okay, so then let's try this. 1, 3. And then this. Okay, so if I do this one, common factor out the 4. And you get 1, 2, 8, and a 6 and a 3. That's a 1-2 ratio. So what we were always told is that you look at the coefficients to see if it's even possible to get the proper ratio. So I'm liking that. I'm going to try that, right? And sometimes you go the wrong way, but I'm going to try it. I'm going to rewrite it. You don't have to. See, I wrote the first, the third, and then this one with that one. Okay, let's look at my common factor. For the first 2, I'm getting 4. That's it. Okay, 4. And I've got a squared minus 2b. Is that okay? And then here, common factor between those two would be, what do you see?
3a.
Yeah, 3a. Minus 3a or positive 3a?
Positive.
Okay, so positive, and then we're going to go bracket negative 2b plus a squared. Did you see that already, the sign? Is that why you chose positive? Yeah, right? So if you chose negative, these two would be backwards. And then all you have to do is go, shoot, I got the wrong sign. Okay, so if you chose negative, you'll notice that they're almost the same, but they would be backwards. So yeah, so if you choose this positive, then it's the right way. Okay, and a way that you could prevent that is that try to go descending order, but sometimes I just don't look in time. I'm just like, I don't know, I didn't look. So, but when you do the sign wrong, you just fix this sign and then you got the right one. So now look, we have common factor. Those two are the same. A squared minus 2b is the same thing as minus 2b plus a squared. Which way do we want to write it though? We want to write it without beginning with a negative. So don't start it with negative 2b plus a squared. It's the same, but wrong, slightly wrong, communication-wise. And then what's left over? Sorry, question? Yeah.
I did the same way, but I also kind of I got a different way of finding that answer.
Yeah, so if you do 1 and the 4 and that one, it also works.
Yeah, that's right.
Yeah, perfect, right? So it works as well if you had taken the 4a squared to the 3a cubed and those two, and you're still going to end up, your common factor was this one, and then our common factor is the other one. Yeah. Yep, so there's more than one way with the 2 by 2s. Okay. And then just don't start a bracket with a negative, and you're good to go. Okay, last 2. Let's see. What do you see? A 2 by 2 or a 3 by 1? So first we go 2 by 2 would be Those first two, it's a difference of squares. M minus 5, M plus 5. Oh, that's not 5. Right? So as soon as I see the coefficients are off, you really can't continue with that one. Then I'm going to try 1 and 3. So those two. But I still have a 25 and an x. I'm stuck. There's m's and x's. They're flying around. So look for the 3 by 1. Do you see the 3 by 1? Which three terms make a trinomial? Yeah. Okay. Which three terms will make a trinomial?
X squared minus 10x plus 25.
That's it. Perfect. So now this one's a bit of a trickier one. So we're going to put another. These ones are all a bit tricky. I think this one is the 2 by 2, not too bad because you've seen it more. This one here is again taking one more step to what I just did. It's a trinomial, but see how it begins here? You know that other one here, it feels backwards, right? This feels backwards to me. So I like to rewrite it because factoring that way always throws me off with the signs. I'm not sure which one's negative anymore. You don't have to. If you can do it fine without rewriting it, that's good. I feel like it's backwards to me, so I do this. Okay, and this helps me keep my signs in order. I want that one first, so it's going to be minus x squared minus 10x minus 25. Okay, so I like it in descending order. It just, for some reason, it clicks better with it. You don't have to, right? So I got my trinomial. Also, I don't want to begin that with a negative, right? I hate factoring with the negative first. So I'm going to do this minus, and then I'm going to do this. Red's okay, right? Red shows up. Okay. X squared, this is going to be plus 10x plus 25. Now I can factor that trinomial without worrying about, wait, that's a negative, that's another negative. Is it part of it? Is it plus? Is it minus? So I get rid of the negative there, make this positive, and now I have a perfect square trinomial. Okay, otherwise the signs get messed up. I've had students try it without doing that. Your negatives and positives gets all mixed up. Okay, so let's get rid of the negative here. Just keep the trinomial clean, and it's much easier, and you're not going to lose a sign here or there. This is going to be x plus 5 squared. Do you see the difference of squares? Perfect square, difference of squares again. Okay, so hopefully you see the pattern now. You're like, and then now you want me to do the square bracket thing. So I do the square bracket sometimes because it triggers your memory, and you go, right, is that when I do the square bracket thing? Yes. It could be round brackets, like I said, but sometimes you go, wait, I need to break it up again. That's the next step that I picture. So go M and M, right? M and M separate. Now this is, again, adds one more place you don't want to lose a mark. I want to go minus x plus 5 and plus x plus 5. Do I need those brackets? If I didn't here, then if I wrote negative x plus 5, is that correct? No. So you need the brackets first, and then you're going to bring it in. 1, 2. Did I need the bracket here? No. Plus doesn't matter. But the negative, you have to distribute that in. So I'm going to put a little star there. Don't drop that negative too fast. And the reason why is because the bracket's secondary, right? So it's after the negative. So the first time these other ones, they were first. The ones up here, it didn't matter. If they're second, you have to distribute. If you can do it all in one step if you want. Yeah. Yep, so as long as I see in this step, I'm going to see this, right? Minus 5. Yes, I'll look there. So here, if I see the minus 5 right there, you're good to go. Right? So if you want to go, I know to bring it in your head and make sure it's a minus 5. That's what I want to see, is that you did bring it into the second term. 1, 2. Okay, if it's a plus, nope, you missed the bracket and you didn't know to bring it in. So I want that one. Okay, so just be careful of that. That one's a bit tricky because people go, darn, I'm dumping my brackets too fast, right? Okay. Last one. Star. 2 by 2 or 3 by 1? So if I do 2, that is a... Yep, difference of squares, right? Are we recognizing it now? Perfect square, m squared, n squared. We're good? Not difference of squares. Can I do anything with that, though?
Yeah.
5, right? 35, okay, so I can take a 5. Now wait, if I did a difference of squares, what would I get out of that? What would the coefficients become? 7 and 6. Am I going to get a 7 and 6 out of here? Oh, happy day. I can finally use my difference of squares. Okay, so then let's try this. So I'm not going to try the other 2 by 2 or 3 by 1 because I want to try this first. So let's go. So this becomes 7m minus 6n times 7m plus 6n. Is that okay? Okay. The second part here is minus, or no, plus, and I factor out a 5. This is 7m minus 6n. Oh, close. Oh, wait. It is right. You're usually going, oh, it's not. It is. Look. This and this are common factors. We did it. It's just a weird looking common factor, but don't say that about it. Because once you take it out, it's gorgeous. Right? So you're just going to take that one out. Feels a bit longer. Okay, but you're taking out the common factor from each set of the terms. So we're going to go, okay, my common factor is 7m minus 6n. We're okay. Take that out of both. And what's left over? What's left over? No, wait, go left to right. Yeah. Yeah. There you go. Okay, so we're going to go, what's left over? That one and that one. Okay, anything else I can do? Nothing I can do. These ones are hard. I did go over some of the hard ones with you, so make sure you practice. There's oodles of types in the homework. Fun, fun, fun. Okay, so 2.3, you're finishing up 2.3 hopefully tonight, your homework.